Okay, this is going to be number one from the 2019 Calc AB and Calc BC exams. And it's about fish in a lake, and it's really just a rate in, rate out problem. So let's take a look. So the first thing I want to do is identify the rate in and the rate out. So we're told fish enter a lake at a rate modeled by a function called e of t. So that's going to be our rate in is e of t, and that's 20 plus 15 sine of pi t over 6. And then fish leave, so that's going to be the rate out, at a rate modeled by a function called L of t. And L of t is 4 plus 2 to the 0.1 t squared. So both functions are kind of messy, but it's a calculator question, so it doesn't really matter that they're messy. So what I did first was just define everything on the calculator. So I have e of t defined, I have L of t defined, and I'm going to use those throughout the problems. So the first part, it says both e of t and L of t are measured in fish per hour, and t is measured in hours since midnight, which is t equals 0. All right, so part A. How many fish enter the lake over the 5-hour period from midnight, which is t equals 0, to 5 a.m., which is t equals 5? Give your answer to the nearest whole number, so the whole number of fish. All right, so this is just going to be the number that enter the lake is just going to be the integral of the rate in. So the integral from 0 to 5, the rate in is e of t, and then dt. It's a calculator question, so grab your calculator. I just did the definite integral. I get 153.458, but then we have to round to the nearest whole number. So I'm going to say it's about 153 fish. All right, and that's part A. Let's take a look at part B. So part B is what is the average number of fish that leave the lake per hour over the 5-hour period from midnight, which is t equals 0, to 5 a.m., which is t equals 5. So average value of a function, the average number is the average value of this L of t. So the average value is going to be, in general, average value is the integral divided by the interval. So that's how I always think of it. And in this particular question, I'm going to do the integral of the rate out is L of t dt divided by 5 minus 0. And then, again, it's a calculator question, so you grab your calculator, and you get approximately 6.059. And then the units on this are the same units as L of t, and L of t is it's got to be fish per hour. So fish and then per hour, I guess. You can see I'm filling that in there because I got the units wrong. So it's going to be fish per hour. It doesn't actually ask you for the units, so I don't think there's a point associated with the units on this. All right, let's take a look at part C. So part C says, at what time t between 0 and 8 is the greatest number of fish in the lake? So we're looking for a maximum on a closed interval. So this seems like a candidates test question, but I'm actually going to do it a little differently, I think, because I don't know how many fish there are to start with. And let's just take a look at the problem overall. So what I'm going to start with is define a new function for the total rate of change of fish in this lake. So the total rate of change I'm going to say is r of t, and r of t would just be rate in minus rate out. And now it's going to be easier to talk about this. So what I want to do is I want to figure out when r of t is equal to 0. Right, so I'm looking for essentially critical points of the fish function, I guess. We could have defined a function called f of t, which would be whatever you start with plus the integral of r of t dt. So this is the total rate of change. So I'm going to set it equal to 0, use a calculator. I got 6.204, so I got it two different ways. First, I just used solve. So you can see I defined r of t, I used solve, but it gives me that yield sign, which says more solutions might exist. And so that always makes me nervous, especially on the AP exam. So then I graphed r of t, but you can't actually graph r of t. So what I really did was I graphed r of x. If you graph r of t, nothing will show up. And the advantage of seeing the graph is I can also see where this overall rate of change changes from positive to negative, right? So I can see kind of the number line or the sign chart that I might have made. So at this point, I'm ready to kind of answer the question. So I'm going to say, since r of t changes from positive to negative at t equals, or approximately equals, 6.204, I know that the number of, so I'm dancing around what to call this, so I'm going to say the number of fish in the pond or the lake is a relative maximum at that t value. Okay, so I know it's a relative maximum. I also know that between 0 and 8, 6.204 is the only critical point for the number of fish function. So I'm going to say, since it's the only critical point on that interval and it's a relative maximum, it must be the absolute maximum. So I just want to address that issue because I could have done the candidates test and I just would have looked at 0 and at 8 and at 6.204. But instead I chose to do it this way. I like to do this way whenever there's only one critical point. So we definitely are getting a relative max, and since it's the only critical point, it's the absolute max. All right, and let's look at part D. So part D says, is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m., so at t equals 5, and explain your reasoning. So this, I'm just going to import r of t, which is the total rate of change, and this question is basically saying, is r prime of 5 positive or negative? So let's just find r prime of 5. Calculator question, so we use the calculator to find the derivative. We get negative 10.723 since r prime, and now let's just write it up, right? So since r prime of 5 is less than 0, the rate of change in the number of fish in the lake is decreasing at 5 a.m. So this is a pretty standard rate in, rate out question. I guess part C is a little bit different because they didn't tell you how many fish are in the lake to begin with. But I think pretty straightforward. I hope you found this helpful, and good luck.